Hello, I am David Mahler, and this video is about working with Git remotes. In this video, we will define remotes in Git, create a repository in GitHub, clone that repository locally, which also creates our first remote named origin. Utilize the git fetch and git merge commands to download and integrate changes from a remote. Make local changes and upload them to a remote with git push. Learn about remote tracking branches. Create and learn about forks in GitHub. Look at how to add and remove remote repositories. A prerequisite for this video are the topics covered in my two videos, Introduction to Git Core Concepts and Git Branching and Merging. Before starting this video, you should be comfortable with the Git commit history, the working tree, and the staging area. You should also be familiar with working with branches and merging branches. I'll link to those videos in the description of this video. Previously, I did note I would be covering altering Git history like rebase and amend. That topic I did decide to save for a fourth and final video. Otherwise, that topic would have been unnecessarily rushed for adequate coverage. The only reference for this video is Scott Chacone's superb Pro Git book, which is available online and in print. Great, so let's start by describing what a remote is. Define Git remotes. When we are working in a repository, a remote is simply a repository in another location from where we are currently working. For example, we may be working on a repo on our laptop. A version of that same work may be on GitHub. From the perspective of our laptop, GitHub is a remote repository. When there are changes to the repo at the remote, we can then download those changes to get them locally. If we make changes to our local repo, we can upload those changes to the remote. For this video, we will work with the public github.com. However, keep in mind that remotes can be any location with a Git repository under a number of different platforms. Some examples are a plain Git server with a bare repository, GitLab, Gerrit, or Bitbucket. A remote can be a copy or fork of a repo within GitHub. A remote can be a repo on a coworker system. It can even be another directory on our same local system. GitHub. We are going to create a repo in GitHub. Before we do that, let's take a look at a diagram to see what we are about to do. So we will start in GitHub. We will work with the demo user Betty-remote. Under Betty's account, we will create a new repository named netauto. When we create the repo, GitHub will initialize it with a single commit and a seed file named readme.md. The repo will start with one branch, the default named master branch. Next, we will work on a local system like our laptop. We want to use our new repo from GitHub, but we want to do it locally. To do this, we will download a copy of the repo. The git clone command will retrieve the project. We will type git clone followed by the location of our new repo. Our project will be from GitHub under the account Betty-remote and named netauto. From the perspective of our system, GitHub is a remote repository. We will be able to retrieve or fetch updates from the repo in GitHub. We will also be able to upload or push updates to the remote in GitHub. When we fetch or push updates, we don't need to remember the full location of our remote. Instead, Git can hold a short name or alias to that location. The default first name is origin. So origin for us will point to the netauto project in GitHub under the account named Betty-remote. We are only going to perform some basic tasks in GitHub, so you don't have to know it well already. However, keep in mind that the focus of this video is Git remotes, not actually GitHub. If you want more detail on using GitHub, please refer to their online doc pages. For the purposes of this video, I created two user accounts. The first account will be our primary user, Betty. Let's create a new repo under Betty-remote now. Create a GitHub repository. We will create a new repo under the account Betty-remote. The content of this repo is irrelevant for this video. We just want to work with a text file or two. Since I am a network engineer, we will start with a phony network automation repo. To create a new GitHub repo, we press the button Start a Project. This action takes us to the Create a New Repository page. Let's name our repo NetAuto. We will keep the repo public. This means everyone has access to read our work. We can now select Initialize this repository with a README. When we choose this, GitHub will create a file readme.md. Readme.md is a markdown type file. This file can be used to add useful details about our project for people viewing it. Let's hit the Create Repository button. Our repository is made and it has a single commit. GitHub made this commit automatically to add our first file readme.md. Now that we have a repository in GitHub, we want to retrieve a copy of this to our local laptop. In other words, we want to clone this repo. To perform the clone, we need the proper URL. We get that location right here at this clone or download button. We have an SSH option and an HTTPS option. For this demo, I'll use the SSH option. We will copy this address. When you use the SSH option, you do need to put an SSH public key in GitHub. In the video description, I'll link to the official documentation on how to do that. Git clone. We are now on a laptop running Ubuntu and it has Git installed. We can say this is Betty's laptop. We know we created a new repository at github.com. Let's clone it using the address we copied. Git clone, and we paste the location. So we are retrieving this from github.com, from the Betty-remote account, and we want the NetAuto Git repo. Now we have the project cloned. We go into our new project by changing to its directory, cd netauto. Quickly, we will set our Git username and email. We need this for our Git commits to log our work correctly. Git config --local user.name Betty. Also, we will set the email, git config --local user.email, and then Betty's email. Our local repository is set up. As a result of the clone operation, we also have our first remote. Git remotes. The command git remote displays our remotes. We have a single remote and its name is origin. After our clone, origin is the default name for our first remote. When we add the -v option to git remote, Git shows us full locations. We can see here that a git fetch and a git push to origin both resolve to the NetAuto repo under the account Betty-remote in GitHub. Let's take a look at the commit history graph. In my earlier videos, we added a special alias to view our commit graph. Let's use that again here. We're going to make the alias graph mean git log with the options all, decorate, oneline, and graph. Let's check that out by typing graph. Our NetAuto repo has a single commit in its commit history. This commit was the one GitHub made for us to add the file readme.md. Locally, we only have the master branch, which points to our single commit. Also, we have our symbolic head pointer, which tells us that we have the master branch checked out. In addition to the local pointers or references, we have something new. We have origin/master and origin/head. Origin/master is a specialized branch. It is called a remote tracking branch. The job of this remote tracking branch is to tell us what the master branch looks like at origin. The remote tracking branch origin/master is telling us that our local master branch and the master branch in GitHub are pointing to the same commit. In other words, our local repository is in sync with our remote named origin. The remote tracking branch is not the same as a standard local branch. We can check it out with git checkout origin/master. Checking out the remote tracking branch works, but we end up in a detached head state. That's fine if we want to look around at how things stand at our remote. However, normally we do want to stay on our standard local branches. Let's dive more into the idea of a remote tracking branch in the next section. We will start by making a new commit in GitHub. We will download and integrate that update to our local project. To do that, we will utilize the git fetch and git merge commands. Git fetch and git merge. We start back in GitHub under the Betty-remote account. In the NetAuto repo, let's add a new file. I'll hit Create New File here. The file will be named S1. I'll paste some data into this file. It is some YAML data for a network switch. For our purposes, the file content doesn't matter. At the bottom, we can select Commit New File. We will leave the default commit message of Create S1. This action created our second commit in GitHub. On our local system, we don't have this new commit yet. Let's get the new commit down to our local machine. We are back on our local system. From here, Git doesn't yet know about the new commit at origin. Git doesn't automatically investigate how things stand at remotes. To have Git reach out over the network, we run git fetch. To demonstrate this, let's check Git status. Here, Git says we are up to date with origin/master. However, we know this is not true. We are not up to date. Let's run the graph command. In the commit history, we see the same thing. We only see one commit. Locally, Git incorrectly believes origin/master is on the first commit still. To be updated, we use the git fetch origin command. Our system reaches out to GitHub. It finds the new commit and brings it down. Now that we've run git fetch origin, let's run git status again. Here, the output accurately reflects that our local master branch is behind origin/master by one commit. With the graph command, we see more detail. We see two commits. At origin, the master branch is at the second commit, where S1 was added. Locally, we are still at the first commit. We'd probably like to integrate or merge the changes from origin into our local master branch. To catch ourselves up to where GitHub is, we use git merge. Specifically, git merge origin/master. We are merging the commit referenced by origin/master into our local master branch. This merge resulted in a fast-forward merge. ls shows we have S1 now in our working tree. The graph command shows us we are in sync again. Our local master branch and the master branch at origin are at the same place. Let's quickly review what we did. We added the file S1 in GitHub and committed that. Our local system was not aware of the change until we ran git fetch origin. After running git fetch origin, our remote tracking branch origin/master advanced to the second commit. We then integrated this new commit into our local work by running git merge origin/master. Before we move to git push, I have one more comment on fetch and merge. We also have the git pull command available to us. Git pull combines git fetch and git merge into a single command. My suggestion is usually to stick with separate fetch and merge commands like we did a moment ago. Keeping them separate gives you a more deliberate workflow and can help to avoid some unexpected merge results. Okay, so we saw how to receive updates from a remote. Now let's make a local change and push that up to origin. Git push. In our local repo, let's make a small change to our file s1. Let's edit s1. I'll use vi, but any text editor will do. vi s1. I'll change the management IP of s1. Then I'll save and exit. We can commit this change with a single command. Git commit -a-m new management IP for s1. With our graph alias, we can see our new commit. We see we are now locally one commit ahead of the tracking branch origin/master. Git status reveals the same. We are on master and we are one commit ahead of our repo in GitHub. To push up our change, we use git push origin master. We are pushing our edit to our remote named origin and to the master branch at origin. Keep in mind this push relies on GitHub authentication. I pre-set up SSH key authentication in GitHub. Now with the graph alias, we see our tracking branch is updated. It is caught up with our local master branch. If we take a quick look at GitHub, we see the change. There are now 3 commits here. We see the latest commit message. We also see the latest commit hash. We can see that origin is updated. Up until now, we have been working with a single remote. Next, we will look at adding a second remote. We will start this process by creating a fork in GitHub. Create a GitHub fork. In this section, we are going to look at things from the perspective of a second user, Bob. Bob wants to work on the NetAuto repo owned by Betty. Bob does not have write access to the original NetAuto repository. He can't push changes from his local system to the existing repository. One option Bob has is to fork the repo in GitHub. A fork creates a copy of Betty's repo in GitHub. Bob will be the owner of this copy. Bob can then do a git clone, but against his fork of the NetAuto repo. Now Bob can work locally on his laptop. He can make a new commit, new branches, and so on, and then push that work up to his fork of the NetAuto repo. Let's create that fork now. We are in GitHub again, but this time we are logged in as Bob-remote. We are looking at the NetAuto repo. The repo is in Betty's account. On the top right is a button labeled Fork. We can use this button to create the fork. We see GitHub creating the fork. Now GitHub brings us directly to the fork. It's the same NetAuto repository, but it is under Bob's account. We see a note that we are currently in a fork. Let's clone this forked project to a local system. Under the green clone button, we see the address to use to clone this. We will copy the SSH-based location. Let's go to Bob's local system. On Bob's system, we run git clone and reference his fork. The clone is complete. Let's move into the new NetAuto directory, cd netauto. Git remote-v. Git remote-v shows us the Git remotes. We see the remote named origin. However, for Bob, origin points to his fork of NetAuto. Let's see a quick diagram of where we are. We made a fork as the user Bob. We cloned the fork down to Bob's local system. From the local system, The remote named origin points to the fork in GitHub. There's a good chance we want to stay in sync with the original repo as well. To do that, we will need to add a second Git remote. In the next section, we will add a remote named upstream. So from the perspective of Bob's local system, origin will point to his fork. Upstream will point to Betty's repo. Let's do this now. Add a Git remote. We are back on Bob's system. To add a remote, we use the git remote add command. We are giving the remote the alias or short name of upstream. The location of this remote will be Betty's netauto repo. If we run git remote-v, we can see two remotes now. We have origin pointing to Bob's fork. We also have upstream pointing to Betty's repo. If we ever want to remove a remote, we would use the git remote remove command followed by the remote name. For example, git remote remove upstream. Now Bob has a link to his fork or origin, as well as Betty's upstream repo. What happens when there are updates to the upstream repo? Next, we will see how to keep Bob's local repo and his fork in sync with upstream. Stay in sync with upstream. We are on Bob's local system. First, let's run the graph alias command. We see 3 commits. Our local system and our origin are at the same commit. Notice that we don't have a remote tracking branch for our new remote named upstream. We have to run git fetch for this. Git fetch upstream. Now, graph shows a new tracking branch, upstream/master. Upstream/master reflects the state of Betty's master branch in GitHub. Origin/master reflects the state of the master branch in Bob's fork. Let's add a new commit to Betty's master branch. We will flip over to Betty's local system. On Betty's system, we will add a new switch S2. We can make this easy on ourselves and just copy S1. I'll give S2 a different IP address through VI S2. I'll use the search and replace functionality of VI to update the management IP in this file. We will change 1.111 to 2.222. I'll save and exit. Git status shows the new file. Let's stage and commit that. Git add S2. Git commit -m add switch S2. Graph shows us Betty's local master branch has moved up. She is out of sync with her origin. We can push the change up to Betty's GitHub project. Git push origin master. Now graph shows she is in sync with origin. Let's flip back to Bob's local system and see how this looks for him. Graph shows Bob doesn't see the new commit yet. He won't see it until he runs git fetch upstream. So this time, Bob is checking for updates from upstream, not from origin. Running graph again shows the new commit. The tracking branch upstream/master has moved up. Both Bob's local repo and fork are out of sync from Betty's repo. Let's sync them up now. Git merge upstream/master. This command merges the commit from upstream in the master branch into our local master branch. Now graph shows we are finally caught up locally. The local master is at the new commit where upstream/master is. The only thing lagging behind is Bob's fork, represented by origin/master. Git push origin master. Now the graph command shows we have all three repos in sync. Let's wrap up now with our final topic. This whole time we've only been working with the master branch. In this last section, we will have Bob create a new local branch, push it up to his fork, and create a pull request in GitHub. Remote branches. Bob wants to contribute to Betty's netauto repo. He has a small edit for the switch file s2. We will start on Bob's local system. Locally, he has a master branch. He wants to preserve his master branch. He wants to keep it clean and in sync with Betty's master branch in GitHub. For this work, we will create and check out a new branch on Bob's system. We will name the new branch edit-s2. On the edit-s2 branch, we will make a small change to the s2 file and commit that change. Next, we will push this new branch up to Bob's fork in GitHub. The push creates the edit-s2 branch in GitHub. From Bob's fork in GitHub, we will issue a pull request to the original netauto repo. The request is for Betty to merge our new edit-s2 branch into the master branch of her repo. We are effectively asking Betty to merge our new changes into the main project. If Betty does the merge, we can do some cleanup work. We can delete our edit-s2 branch locally and in GitHub. We can also resync up our master branches locally and in GitHub. Let's do this work now. Here we are on Bob's system. First, we create and check out a new branch with one command, git checkout-b edit s2. Git branch shows our new branch edit-s2. We can see that we have edit-s2 checked out. Notice here that the git branch command does not display any remote tracking branches. To see local and remote tracking branches, we can use the -a option. Alternatively, we can use the -r option. With -r, Git displays remote tracking branches only. So far, we don't have a remote tracking branch for edit-s2. We don't have it because edit-s2 isn't in GitHub. Let's make a small change to the s2 file. We will just change port 1 from VLAN 10 to VLAN 20. We commit our change with git commit -a-m update s2. With graph, we see our new commit and our new branch pointing to that commit. Now we want to upload our work to Bob's fork in GitHub. Git push origin edit s2. We are pushing the new branch edit s2 up to origin or Bob's fork. The graph alias shows that we now have a remote tracking branch origin/edit s2. It is at the same commit as our local edit s2 branch that we have checked out. Let's go over to GitHub and see where we stand. Right now, we are in Bob's GitHub account. In the netauto project, we are on the master branch. If we want to check out the new branch, we can use the branch dropdown and select Edit S2. GitHub shows us that this is one commit ahead of Betty's master branch. From the Edit S2 branch, we can make a pull request. We use the New Pull Request button. We are looking to merge our Edit S2 branch into Betty's master branch. I won't cover the pull request process in detail since that is GitHub specific. At the most basic level, we can just update our commit message and include a longer description if needed. When we are ready, we hit the Create Pull Request button. GitHub will then send Betty a notification about the pull request, or PR for short. At that time, Betty can take different actions. This includes reviewing the change, adding comments, requesting alterations, asking others to review, approving and merging the request, or closing the request to deny it. When the PR is done, we can then do some cleanup work, like delete our new branch locally and in GitHub. We can also resync up our master branches locally and in our GitHub fork. Alright, that wraps up this video discussing Git remotes. I hope the video was helpful to you and makes your version control projects clearer and easier. Again, I'm David Mahler. You can find me on LinkedIn. I've also started to actually use my ancient Twitter account, so you can find me under @DavidMahler as well. As always, feel free to leave feedback in the comments section and please subscribe for more. I hope you have a wonderful day.